Welcome to Tech Tips. This is Dan Featherstone, and today we'll be reviewing the components of a single-phase motor. So with that, click anywhere on the screen and let us begin. This is the back of a Regal Beloit motor, or as it has been known in the past, an A.O. Smith motor. This is our primary centrifugal and jet motor partner, and we're reviewing this type of motor and configuration. You may see different configurations in competitors' units, but most single-phase motors have these basic components that we will discuss in some way, shape, or form. This is a line drawing of the same components, including the thermal overload, capacitor, switch, governor, and the terminal board. The terminal board is where the voltage comes in at line 1 and line 2. There are a variety of boards shown here depicting the different methods of changing voltage over the years. The most current is the black and white picture in the lower right-hand side. Note all 4 motors go out wired 230 volt unless otherwise noted on the motor or in the manual. This is to prevent accidental damage to the motor should the wrong voltage be applied. A test to proof the motor is a winding test. The procedure to test the windings vary from manufacturer to manufacturer. Refer to the owner's manual for further information on this procedure of testing the windings. This is the start capacitor. Do be cautious, it can hold an electrical charge, so be careful handling it. In the photo in the lower left-hand corner, you will see a capacitor from the top down. If there is any damage or debris on top of this unit, it may not function properly. As well, the light tan indentation is a pressure relief cap. Should that be open or leaking oil, the capacitor will also not function. The capacitor is needed only to start the motor. It sends voltage to the motor through a switch and is controlled by the governor. It has a safety in the thermal overload should the capacitor be damaged or stay in the circuit too long. When in doubt, check the capacitor with a capacitance reading meter. This capacitor is a replaceable part, often sourced locally. The start switch and the governor work together. When the motor is stopped, the governor is closed and pushes the points together, waiting for the control to pass current to the motor to start. When current is applied, the motor begins to spin with aid from the capacitor. It spins up to about 2400 to 2800 RPM, and then the governor will open, taking the switch out of the circuit. When the voltage is removed by the control, the motor stops spinning and the governor closes, ready to pass voltage again when called upon to start again. The governor and the start switch, should they become damaged, are often replaceable. The thermal overload is a heat-sensitive disconnect. If the starting capacitor stays in the circuit too long, or the motor is pulling higher than expected amps, the heating element will get hot and the switch will fall out of the circuit. Once it is cool, the switch will automatically click back into position and be ready to try to run again once it sees voltage. This is a whiteboard drawing of the thermal overload. For this type of overload, an ohms meter should be less than 1 if reading from contact 1 to 2 and from 2 to 3. If measuring from 1 to 3, the ohm meter should read out of limit. Depending upon the manufacturer of the motor, the overload may be replaceable. It is often advised that when service is needed for any motor, an electrical motor professional should be contacted to service this motor. Often an issue with the thermal overload indicates a bigger problem within the motor. In the need to remove the impeller from the shaft, it is advised to do so as follows. Be sure to turn off the power and disconnect the incoming power wires to ensure safety. You will need a 7/16 inch open-ended wrench. Approach the motor from the top. Underneath the thermal overload, there is a gap created by 2 posts supporting that thermal overload. You can successfully slide the wrench into this area until it comes into contact with the motor shaft. Once in contact with the motor shaft, you can turn that motor shaft by turning the impeller until the wrench falls into place with the notches of the shaft as shown in the lower left-hand picture. The motor components were removed to give you a better view of the shaft end. Once the wrench has locked the shaft in place, the impeller can be removed by hand spinning it counter or anti-clockwise. To recap, voltage enters the motor through the terminal board. The start capacitor is an aid to start the motor only. Once it is started, the governor and the switch fall out of place, taking it out of the circuit. The thermal overload protects both the motor and the start capacitor should there be an issue. And finally, remember a 7/16 inch open-ended wrench and approaching in the motor from the top behind the thermal overload will secure the shaft and allow for easy removal of the impeller. With that, this is Dan Featherstone saying thank you for joining me for another Pentair Tech Tip. Have a great day and be kind to each other out there.